The question is, here the particle of mass m is moving under the force of derivative power p. Initial velocity of the particle is 0, so you have to find the position of the particle at time t is equal to 4. Right. So we know that power is equal to force into velocity. It's the dot product of f and v basically. Right. So here we are talking about linear motion, so we don't have to consider vectors and all. So if p is constant, I can say f, that is f is equal to ma, that is p upon v here. Right. So I can say acceleration, that is dv upon dt, is equal to p upon mv from here. I can say acceleration is p upon mv, this. So we have the differential equation v dv is equal to p dt upon m. So at time t is equal to 0, the velocity was 0. At any time t, let's say the velocity is v. We do the integral here, v dv. Integral is going to be v square upon 2 for limit 0 to v. And this side here is going to be pt upon m. Right. So we get v square upon 2 is equal to pt upon m here. Fine. So that means the expression for v is going to be 2pt upon m and the square root of this thing. So we have the expression for velocity, but the question is asking the position at the time t. Right. So we can again make one more differential equation. This v I can write as dx upon dt. Right. This v is nothing but dx upon dt. So I can make this one as dx upon dt, that is the velocity, is square root of 2p. This is a constant. And this is root t, that is 1 by t. This root t that was inside, I have written as t to the power 1 by 2 dt. Right. Integrate. And here we have to assume that initially the particle was at x is equal to 0. And at time t is equal to 4 we need. So let's say x is the position at time t is equal to 4. So if we do the integration again, this thing here is, so dt comes here, dt has come here, right? So it's like this, dx is equal to this time dt. So we have x is equal to the square root of 2p upon m is a constant. So we are left with integral of this thing only, right? So this is straightforward integration. This is equal to square root of 2p by m is as it is outside. And the integral of this thing is going to be t to the power 3 by 2 upon 3 by 2, that is 2 by 3. So this is the expression for x, right? So finally what I'm getting as the answer, x is equal to this thing here. I'm just rewriting it, in a proper manner. 2 by 3 root 2p upon m and t to the power 3 by 2. T to the power 3 by 2. And the limit for x is from 0 to 4. Right, for the limit of t is from 0 to t, so I have to put limit 0 to 4 here. So that will give you, if you put t is equal to 4, is going to be 8. So ultimately this is going to be 16 upon 3 root 2p upon m. So this is going to be the answer, right? The position at t is equal to 4 is going to be 16 by 3 square root 2p upon m. So this option here, first one, becomes the correct answer for this one. Okay. Thank you.